Hi everyone, welcome back to Radel AI. If you're just joining, we are an AI agency specializing in helping SMEs integrate AI into their workflow to streamline their processes or save them costs by removing human bottlenecks and pretty much automating the entire process. So today we're going to be diving into what AI orchestrators are and how we implemented an orchestrator for one of our clients, and then explaining the best practices around it and how maybe you could implement it into your business. So let's dive in with what an orchestrator is. So think of the orchestrator as the brain of your ecosystem. Its role is to interpret the incoming queries, deciding what needs to happen, delegating the task to the right agents or tools, and bring the results together in a way which you can give to the end user in a coherent way. And without AI orchestrators, pretty much agentic workflows are like an orchestra without a conductor. It's chaotic, uncoordinated, and inefficient. So let's dive into different types of orchestrators. Pretty much to give a fundamental of what orchestrators are, imagine this orchestrator is an AI agent or is an LLM, and it knows that it can call different agents or different tools, and its role is simply to understand what the input is, figure out which tools to call. Then there's going to be a synthesizer which takes the outputs of all the tools with context of the incoming input and then returns it into a coherent output for the user to see. So the first type of orchestrator is a centralized orchestrator. And this is pretty much a model of a single master agent which coordinates an engine and acts as the brain of the system. So this agent oversees managing other agents, directing them, assigning tasks, getting back the data, making it flow into maybe other agents if it needs to, and making the final decisions. And the pros of this system is purely it's easy to monitor and troubleshoot because that one agent is deciding the entire flow. At the same time, it ensures like consistent decision making because the better that you prompt and engineer that one agent, the less hallucination that you're going to have, which means predictable workflows and ideal for environments with like high transaction volumes. But the problem here is there's a single point of failure, and this can easily face scalability issues as the number of agents that this orchestrator can call increases. So then the second type of orchestrator is a decentralized orchestrator. So a decentralized orchestrator is pretty much, there's no single master agent. Instead, each agent operates autonomously based on whatever jobs need to be done in the task queue and some context that it has about its role. And this allows for flexibility and like a dynamic operation in more complex environments. And since there's no single point of failure, if one agent fails, then the other agents will make up for it and just continue with what they have. And this is more suitable for like large scale global applications, basically providing resiliency while reducing the latency of the tasks to be done. But again, double-sided sword. So this can be more complex to design and implement, and purely because there's more inconsistencies in the decision making, this requires more sophisticated communications and negotiation protocols between each agent. So then finally, let's talk about the hierarchical orchestrator, which pretty much gives us the best of both worlds of centralized and decentralized orchestration. So here, agents are organized into two layers. One layer is the master agent, the other layer is the worker agents. And the master agent has final decision-making power and coordination over the worker agents, but the worker agents have a degree of autonomy which they can talk with each other, go back to the master agent to report a bug, request new information, or ask the master agent to coordinate something else with another agent. So this balances the control with the autonomy. So it's scalable with clear levels of responsibility. This can also handle tasks with multiple layers of decision making because the master orchestrator is doing the heavy lifting while the agents are still able to go and intelligently do their own tasks while talking to other agents. But this is a lot more complex to design than the decentralized agent purely because there's a two-way communication here and also a horizontal communication between the worker agents. So this can create potential bottlenecks, and without careful coordination, there's a lot of conflicts that can happen between levels and within levels. So This is pretty much an overview of the types of orchestrators available. And recently, OpenAI and Anthropic had released best practices for these orchestrators. Let me just quickly walk you through 5 of them. So the first one is like a clear separation of agents and responsibilities. If everything is fit into one agent, it's going to be higher hallucination, the output's going to be bad, latency is going to be high. So as long as each agent is specific for one task and the orchestrator agent is for making sure all of this happens smoothly, the system's going to be amazing. And the second one is feedback loop for continuous learning. So as a human, we are able to talk to other people, internalize what we're doing, what's right, what's wrong, figure out where we need to change and fix everything. But for agents, that's not the case because they're not able to self-learn, which means there has to be a feedback loop, which a human or some other supervisor agent comes in, analyzes the output, analyzes the thought process, what each agent was used for, and then creates a final kind of a teaching document. Hey, you did this, that was good, or you did this, that was bad for these reasons, and fix that in the next iteration. And the prompts will be kept. For each agent, the prompts and the design will be dynamically improved for the next run through. And then since each agent is also very prone to hallucination, their third, OpenAI and Anthropic's third recommendation is have a strong fallback or error handling process so that when one thing fails, it doesn't break the entire system. And the fourth one here is the most important and most fun out of all of this, which is the context awareness. So whether it's a master agent, worker agent, they have to be aware of why they're doing some work, what work other adjacent agents are doing, which is affecting what these specific agents are doing, and then how it all ties in with what the user wants in the end. So these are the best practices recommended by Anthropic and OpenAI. And using this and our knowledge of AI agents, we pretty much built an agentic orchestrator for a fintech company, which is what I want to get into now. So essentially, what we did is our client, they were overwhelmed with unstructured queries ranging from stock data to portfolio insights to financial analysis and even like real-time internet requests. And their old pipeline had a lot of manual routing. There was no unified classification layer, and it had a lot of poor latency and accuracy. So we stepped in to build a custom AI orchestrator that intelligently classifies and routes the queries using OpenAI's GPT models. And we did this purely by testing a bunch of different models from OpenAI, DeepSeek, Meta, Claude, and we realized that the OpenAI models, they were very well in terms of latency and accuracy, and also parsing robustness when we needed to get the right output in the right formats. And even the edge cases like the malformed JSON or ambiguous prompts, they were handled using our custom in-house systems. So once we got that out of the way, we had to figure out, hey, what's the best way for the orchestrator to call these sub-agents to reduce latency and increase accuracy? And that's when we designed a hierarchical pipeline, which is pretty much a request comes in, you have to dynamically identify whether it's a general request, non-general request, financial, non-financial, and then assign subcategories. So pretty much, is this about stock data? Is this about news? Is this about portfolio? Is this about the user's specific portfolio? And then go back to what the user was asking before this to identify, is this something that they need more context of what their portfolio is about, or if it's just a general query, stuff like that. And using that, we routed these requests to specialized agent pipelines like LLM chains, vector retrievers, financial APIs, which came together to give back a coherent output for the user. And then doing all of this, we were able to reduce their latency from 6.2 seconds to less than 1.5 seconds, which is ideal for their level of production scale system. And then finally, what we did, which really wowed them, which was the feedback loop. So our accuracy, we brought it down to, we brought it up to almost 95%. But then using the feedback loop that kept getting better day over day, and they had a human in the loop which will look through the agent's processes and understand how it can be done better, what was done right, and gave the agent enough context to fix it in future run-throughs. So that is pretty much what AI agentic workflows and orchestrators are. This is what we're doing at Radel AI for a bunch of companies, and we would love to do it for you guys as well. So if you want to get in touch with us, just have a free consultation call to understand your workflow and how agentic workflows could streamline your business, reduce costs, and increase revenue. Then please book a link. Please book a call with us using the link in the description below. And we hope to talk with you soon.